My name is Steve Tegeler. I'm a Senior Director of Systems Engineering in VMware's, we call it our Cloud Native Apps business unit. So if you associate a product to that, that would be VMware Cloud PKS and VMware PKS are the two solutions that the BU that I work for cover. And to my right here is Tom Hite.
Oh, I'll introduce myself. I'm
Yes.
Senior Director of Emerging Technologies worldwide for VMware. I concentrate mostly on artificial intelligence, blockchain, network function virtualization, multi-cloud operations, IoT, these kinds of things. So PKS is a big part of that because most of what we want our customers to do is begin to container transition, but we're going to talk a little more kind of down to earth here today, I think, than this wacky stuff.
This isn't a PKS conversation, don't worry about it. This really is applying software design patterns and methodologies to your IT services. What does that mean, right? How do I take some of the methodologies that software engineers and apply it to the services that I have, or that I'm responsible for, and how do I make them more reliable? So, show of hands, who would consider themselves a VI admin, virtual infrastructure admin? That, like, few, okay. And then who considers, actually you want to run through the coding questions?
The coding questions?
You have a whole list of questions.
Do I have to get on stage for this?
Yeah.
All right, now we're on this huge stage, it's really big, did you notice? Who's a software developer? Awesome. We had just a few pure IT admin guys, right? That's what I saw just a minute ago. How many of you guys, don't raise your hands if you're a software developer, by the way. How many of you admins are developers as well? So you guys are pretty well formed actually. Usually it's quite the reverse. I'll get a room of 300-400 people and I'll ask the question, how many are software developers, and like 3 people will raise their hand. Then I'll ask them if they write scripts or if they write like Kubernetes manifest files or something like that. And then the whole room will raise their hand and go, well, you're all developers then. So it's this is an interesting group, a lot of software guys in here, so great.
So here's a disclaimer, by the way, don't buy anything based on what you see in this presentation. So we're going to go through the agenda. So Tom's going to say a few brief words about the whole goal of this presentation and where we need to get to in terms of our skill sets. Then I am going to cover consuming and providing IT services. So first of all, I'm going to define kind of where we all sit in call it the software stack or within silos in IT. I want to talk about communicating or not between teams and how that could potentially work. Operating your IT services leveraging SRE. So I'll define the SRE type function, and then Tom will go in and talk about a few of the unique things that SREs do. So source version control, working with that and the benefits there, configuration management, immutable services and infrastructure, and then CI/CD, and then we'll close out with a demo at the end. So let's, you want to go ahead and talk about the goal, Tom?
Yeah, sure. Go ahead, switch slides. It's okay.
Yep.
So what we try to present to folks a lot is a kind of a split in the developer world, right? The SRE. How many of you guys are familiar with SRE concepts, like reliability engineering? So a few guys. So SRE, where we want to help customers get, once they have their virtual infrastructure, they have a multi-cloud operation going on, or they're doing all sorts of IoT work. We have kind of a split in the world we got to go do, which is there's feature developers in the world, right, who have to write business logic and the kinds of things that make money. And there's cost side developers, which are SREs, right? Their job is to keep, right, the functional software, the functional pieces in the infrastructure up and running, right? So they work in specific principles. But both of these guys develop code. And when we develop code along an operational characteristics for automating, for assuring that things are up and running, and we can maintain day 2 operations, for example, in a codified way. That's what we really, really want. So the shift is, and Gartner kind of called it bimodal IT for a while, but it's really like this. Developers at a feature level want to go at very high speed. They want to do lots of commits, lots of features. Some of them will get through the pipelines and succeed, and they'll pump that out into production. IT guys don't want to move that fast, and for the right reasons, right? The more you stuff into production, the more danger there is, the more risk there is for failure out in the field, right, in real production. So the two guys want to go at different speeds, but they have to work in concert. So what we really want for success is the SRE developer perfecting the nature of infrastructure, and Steve's going to talk about this, kind of the layers of contracts that we want between developers, perfecting that layer so that it will operate at 5 nines regardless of what's on top of it, for example, if you need 5 nines up. And that way, the feature developers can crank as much code as they want through the mix, because even if their software fails, if it's properly written, resilient, we can back it off, but the infrastructure won't break. So that's kind of the goal of what we want to present here today, is how do we do that? Split off and support the feature developer while keeping the admins who, as I just kind of commented, we're software developers, how we get that side of the game really played and how we get our constituent customer base, VMware's customer base, thinking more like SREs than feature developers. So Steve will take you through some of these concepts.
Yeah, so let's talk about just generally consuming and providing IT services here. And if we look at this kind of hypothetical stack of different teams, at the top, we've got something we're calling the application or the feature team. So like Tom said, they're responsible for creating that app on your phone or a little button somewhere or a feature or functionality for the business. They usually have a team, and of course they are developers. They usually have a team that sits between them and infrastructure. I'm calling it the application services team, tools team, platform team, whatever you want to call it. Their job is to offload some of the repetitive tasks from the application feature team. An example would be, you don't want the application team configuring a database, right? They want to go just request a database and use it. So that's what potentially that services team can do. And of course that team also leverages, so they also leverage container services. That's where we've seen that incubated there. And arguably they create basically this application platform that get consumed that just provides different abstractions. And so they're obviously developers. Then below them, we've got the infrastructure operations team. And so obviously physical infrastructure, virtual, and potentially IaaS. And their whole job is, how do I abstract infrastructure complexity from this application services team so they can build their services? Arguably, they write scripts a lot of the time, PowerShell, you name it. They're also developers as well. If the infrastructure operations team is not providing the service that's easily consumable, then that application services team may go out to the public cloud for these basic infrastructure type services. Of course, the public clouds also provide additional services. So the application developers may be going to the public cloud for some more of these advanced abstractions. Okay? So if we look at IT here, in general, everyone is trying to be a little more consumable in IT to the people above them. And so it's really important that we all kind of stand back and look and think, is the service that I'm providing what the people above me want? Is it providing that level of consumability? So containers is kind of an interesting one. I've seen containers really incubated. Container services have incubated on that application services team because they build their services in containers. But what we're also seeing is they have liked to stand up these container services and they play with it, but then they realize, I don't want to actually manage a container platform. So the one piece I'll identify is that the container services sit somewhere in between infrastructure and the application teams. So the application teams, if they don't have to manage like a Kubernetes cluster, that gives them more time to create additional services. Now, arguably, this term reliability engineering is spread across all of the teams. Up here, obviously, the app teams, they're certainly, they have CI/CD pipelines and all these processes associated with development. But as you get further down, a lot of this stuff is still clicking, right? And we need to change that. We need to make it more repeatable and reliable. Between all these teams, there's typically fences, and we always hear about this. You're going to throw it over the fence, and it's someone else's problem. Now, the interesting thing is that in some cases, throwing over the fence might work. And if you think about a classic example, it's a public cloud. How often do you interact with your public cloud system engineer? It's very self-service. You can get all the information you need out of that public cloud if you need to, typically. So the next conversation here is how throwing over the fences might work. And this is probably a bad thing to say, but the reality is it's this word right here that makes it okay. reducing the communication requirements, right? It's good to communicate. Don't get me wrong, but do you have to communicate to get your job done, right? Because if you have to communicate, it may slow you down. So if we look at some various teams here where there may be fences, the obvious, the easy one here is like down at the data center and the physical infrastructure. Okay? So I like to talk about this concept of having contracts between all these various teams. And the contract between physical infrastructure and the data center is pretty simple. It's a 19-inch rack. There are certain power plugs. There's heating and cooling, or it's no heating, just cooling, that exists there between those. So if I'm on the physical infrastructure team, as long as all my devices fit in a 19-inch rack and have a power plug, I can pick and choose whatever I want, completely independent from the data center. Pretty obvious, right? What about up at the virtual infrastructure layer? So the contract I have with my physical infrastructure team is that if I'm running vSphere, I'm x86, of course. I'm on the hardware compatibility list. From networking, I have IP connectivity and MTU requirements if I'm doing NSX. We got IOPS and latency, and is it shared storage? So these are the contracts that exist between the virtual infrastructure team and the physical. And if it's clear of what is okay and what isn't, then I can go down and I can change out as the physical infrastructure team. I can make choices based on what's easy for me to operate and manage, right? And I can do that independent from the virtualization team. If we work our way up, here's some common abstractions. So basic IaaS. I've got Docker listed there, Kubernetes, and maybe platform as a service. So what is the contract between those services and my virtual infrastructure team? Well, it's typically unique to each one of these services, but it usually takes the form of like a plugin, right? So if I have an IaaS that's responsible for quotas and tenancy and whatnot, it needs to have a plugin for vSphere and potentially data stores and NSX and be able to work with it. And so that's the contract. And if my IaaS platform supports public cloud, or well, potentially public cloud services, or even different hypervisors or whatnot, we need to make sure the IaaS we choose has those different plugins. And then finally, above that is the kind of the developer experience, which is, what do they want? They want like this native API experience. They don't want some proprietary piece of software. They want something they can Google how to do something and just go do it, independent of having to call up a team and say, how do you do this on your system? So at each and every layer, there's this contract, and if it's a good contract and everything's understood, you shouldn't have to communicate. You can just consume whatever layer it is below yourself, or you should be able to communicate less. The one thing that's missing here, though, is that if I'm a software developer here and I need to basically design a piece of software, how do I know how reliable these underlying layers are? And so the other piece that it's important here as a part of that contract is to understand the reliability and some of the metrics you can get out of that underlying layer. And so, like, if you just take vSphere as an example, we have vSphere HA, right? And so that will automatically recover a VM. I may be able to leverage that in my overall application development if I know those virtual machines have a high level of reliability. Okay. So operating our part, so whatever part yours is there, we're going to call that reliability engineering, and specifically site reliability engineering. And the term was coined in 2003 at Google. And the idea was that an SRE, site reliability engineer, the site was google.com. And the SRE was responsible for maintaining google.com was up and running. But the reality is, if you have a website, chances are it runs on some sort of infrastructure, or it has an abstraction layer. It runs on infrastructure, that's in a rack, that's got a power cord, it goes to UPS and a power plant. So is the SRE responsible from acme.com all the way down to that power plant? The answer is no. The SRE function exists at a lot of different layers. So you may have the SRE up at acme.com, but then maybe you have additional SREs in each and every team that are responsible for making that service highly available and reliable. So the key here is that the methodology of the SRE is what is important here. And so what you have to do is you have to approach your IT service And the responsibilities of that, like a software developer. So you want to identify all the, repetitive tasks and figure out how to automate them, but automate them the right way. Automate them the software developer way. Don't just create a script to go do something. Check that script in and track it over time and track those changes. So track all changes. You're going to use something called source or version control. Automate as many manual processes. That's going to be potentially configuration management. You want to get rid of long-lived objects. Who's logged into a virtual machine and patched it manually? Do you still do that? That's tough. It makes it hard to manage that and make that predictable over time. So, and then the final piece is creating the workflows and the triggers to manage the service. So don't just a manual person run a script. You want to have this be an automated process where I check in a configuration and the process is responsible for performing that configuration change. So Tom is now going to talk about these 4 bullets here.
Oh, we got those coming up. Perfect. Okay, so those of you who are software developers, you can raise your hand if you want. How many of you guys deal with Git? Right, so a bunch of you, and I can see the rest don't deal with Git. So for the first part of this, guys who are savvy with Git, how many deal with Garrett? Code review tool. So a few guys really have a process, right? The review process is really quite good. We're not going to go into Garrett, but it is a piece. But what we like to do with the source control, just talking source control, there's 4 things we're going to talk about, right? Source control, config management, immutability, and some other stuff. But source control itself is kind of important. What it gets away from is this concept, right? We've got a problem in the data center. 99% of people or customers, I shouldn't say 99, I don't have actual data, but I can surmise it's that because I've been with VMware long enough. The first thing they do is they go run to vCenter because VROps gave an alert or a badge or something, and they run to vCenter and try to fix it, right? And so what they do is they enter a bunch of info, whatever it is on which screen, click a few buttons and magic happens, things are fixed, right? And I don't know why this thing buzzed, I don't know, but in any event, that's what happens. And the changes do take effect immediately, which is good. In emergency situations, maybe you have to do that. But this process is not scalable, right? If you have 100 guys, you can fix 100 problems. That's it. That's all you can go do. What is scalable is dealing with this kind of stuff. If we get out of the run to vCenter and create a snowflake, which is basically you've just done a configuration management thing by hand, then you could never recreate it, quite frankly, because you kind of did something without tracking it, right? That's what Steve just talked about. So what we want to see is a process where you are using version control, and we'll get into why, right? But you write code to go do that change. You don't run to vCenter. You write code and you commit it. And that code would likely be configuration management. And Steve's actually going to do a demo later. And Steve's on the sales side, so he's not technical. But he's literally going to prove that non-techie guys can do code and Git and things that actually work and do a config management thing. We'll talk about that later. But when we're doing configuration management, another thing comes into play, and that's immutability. Can you work? How many of you are familiar with the cattle and pets and kittens and chickens, the world of CNA, right? So many of you aren't. The issue is, do you have long-lived things? Do you have long-lived VMs that the reason they're called cattle and pets is if it's a pet, you're going to take care of it, and you're going to keep that thing alive to the extent you can, right? If it's a cattle, it's in a slaughter situation, right? We're going to make steaks or whatever, we're going to get some meat out of it. But the point is, we don't name cattle, but we do name our pets, and our pets are important, so we have to keep them alive. And what we want to think about immutability is there are no pets. Everything's kill and fill, and that's what we want, right? So that leads us to CI/CD, and we'll talk about that in a second. So source and version control for folks who don't know it, for those of you that are software guys, you're going to be a little bit bored. Git is just a thing to help you keep track of history of files, file directory structures, or whatnot, right? So if you write a script like a bash script, those of you who are writing scripts, if you store it on a zip drive and you run it down the way, that's called a sneaker net or whatever, great, you fixed a script, you ran the script and you did some work, and then you go change the script, right? The point is, now do you have your old version that you could go back to and see what you did before compared to what you're about to go run? And the answer is probably not, because you overwrote the script, unless you did your own version controlling, said, well, this is script version 1, this is script version 2, script version 3, so you got copies of everything, right? Git's job is to do that process very efficiently, right? So it keeps different, it tracks changes a different way, but its point in life is to be highly distributed So you can have hundreds or thousands of script writers or developers or whatever writing code, collaborating on the same place in code, and actually simultaneously committing. So you have a very scalable operation around configuration, right? So if you want to change the anti-affinity rules, for example, on a vSphere cluster, somebody can write a script to go do that, commit it, and hopefully, if we got CI/CD in place, it'll go take action and go do that, right? So they don't have to go to the screen. But the bigger point is, with Git, you have a track of your changes, and this will become clear why we would want to do that over time. So your job is to commit the script into Git, and then push it. It's a push. You have to do another operation, but add it, commit it. And then ultimately, that is going to trigger some operations. If you have a problem, the cool thing is you can you can get an indication of what changed between two versions if you have a bug. Right? That's what you cannot do. So Git just in general is something for version control, right? Source version control, that's what it's for. And this is sort of the thing, it's everything required to go get reliable. Steve talked about reliability, right? How many people know resilience versus availability, for example? Something is really reliable if a user can keep using it, right? When Google.com, the original site for site reliability engineering, right? As long as they can go hit the web page, it's all good, right? That says nothing about what's behind it. That web page could have been cached for all you know. It says nothing about partition events that might occur that have all the systems offline, right? That's availability. So we have a very high level of resilience in that case, because even if the network dies, we can still show the cached page. The user doesn't know any different, but the systems are all offline, right? That's availability, and it's a sliding scale. So we can be highly resilient with very bad overall system availability, and that's reliable as far as the user is concerned. That's what we want to go for. And so what we want to think about with code is how do we get code to help us with reliability, right? And it's like this. If we're going to configure our infrastructure, then our feature code is version 3.1, right? Whatever the version is here. And we're going to configure some OS and app changes. Then what we want to do is do the OS changes with our reliability code, right? I'm going to show you different levels of code here. Feature, infrastructure, and reliability code. But we want to actually version even the code that we're treating as reliable. That means configuration management code and this kind of stuff to help us go through this. Then finally, there's infrastructure code itself, right? All three types of code. So Kubernetes manifests, for example, our infrastructure as code type. Infrastructure as code type code. That's the best way I can put it. So all those three codes we need to keep track of. That's the application, it turns out, right? Because if we're going to modify the application, we could modify a feature. We're going to have to do rolling upgrades or whatever. We can modify some of the infrastructure itself, right? Maybe we need bigger VMs. That modifies the nature of the app as delivered. So the whole thing is the app, and that's what we want to track. That is application, maybe it's 12.34 or something like that. So the application itself consists of multiple bodies of code and probably multiple versions of those bodies of code. This is what Git is for. There's lots of things going on, and we got to track all of that. That's what we need to go do. And so, well, Steve's going to show you this later. I don't need to show you about the YAML files. But the point being is this. The reason source code and running things by code and managing the versions of that code is so good is, one, you can build topology templates, right? Think of VRA. I don't know who uses VRA or whatnot in here, or Kubernetes, doesn't matter. The blueprints, right, in VRA, that's code. And that's something we can template out what our system should look like, right? Kubernetes manifests are code. We can template out what we want the deployment service and services to look like, right? That's code. It's a YAML file, but it's code that we can track, right? And it's reusable and shareable. So if we want truly like replicated systems, right, we can use the same manifest, the same code, and run the same thing in another site. This is what we want. Then therefore it's shareable through the version controls, because we can use Git and we can pull it to another site and execute it, right? And that's how we can easily test permutations. So when you get into the CI/CD game, you hear dev, test, and prod this, right? Well, those are pulling different versions of our application. Remember, reliability code, feature code, and infrastructure as code, right? So it's pulling all of those, but different versions to test them. That way we know which ones we can pump into real production, right? So that's how we promote. So that's what we want, and that's why source control is so great. And then when things break, the whole idea is you can actually figure out what the heck went wrong, because if you don't keep track of your code changes, You're kind of like, well, what did I just change? I think I changed line 53 of, that script over there. Not going to happen, probably, at a high-scale operation. So it looks kind of like this. Let's say we're doing a day 2 maintenance issue, right? And we've got to fix something. And somebody fixed something. We don't know what yet, but we know somebody fixed something, purportedly. And, their code was running through various versions, February, March, April, May. And all of a sudden, we get a security audit. We get an incident report right at the end here. Well, here's the deal. If you had tracked what was going on with Git, right? And you guys who use Git and Git diff and this, you know this. If you had tracked in your scripts what was going on, this is an example, you could very quickly see that, somebody went ahead and opened up port 22. So SSH is now available. So now we have a new attack service vector, right? That is a very quick way to find out what the problem was, because we just have to diff version X to version Y of our application. And the diff can be through the entire code set, right? It doesn't have to be one little file. You can just diff the whole doggone versions of your application. Remember, reliability code, application code, and infrastructure code. So when we can diff that level of code and find this is what happened, then you can very quickly remediate the problem, right? Close the port and fix the problem. So this is what we want. We want to know who did what and when they did it, and that's what version control is all about, right? So obviously that is what deals with configuration management, because if we do configuration management through code, not like running the vCenter, we actually do code to do it, Chef, Puppet, Ansible, Terraform, these kinds of things, then this is the thing. Configuration drift, you guys familiar with the term drift, right? When things change, you would like to know they change, but they change anyway because somebody SSH'd into a machine and changed the OS version. Great. Configuration drift is the nemesis of reliability. If things are changing in operation, you can't be reliable. It's very clear, because you're not quite sure if it's really going to work, because you just changed a production system. That's what you shouldn't do. Manual and track changes is exactly what that is. So if we go fix the server, Steve said who SSHs in and fixes it or patches it, and some guys raised their hands, so you can't do that after this. But that's what's the bad deal, right? That's what makes a snowflake. You now have a completely different system than in the other data center because he hacked this one, right? That's not a good thing. So what we want is consistency and through reliability. So this is an example of that. We know how things happen. We've got automated, let's say we did configuration perfectly, right? We've got Chef doing stuff for us. So we put a bunch of base OSs out there, we got our VMs up, and somebody goes in and hacks up the bottom one and says, you know what, I got to upgrade, this one thing, SSH or Bash or something like that. I just got to upgrade it. So he does an apt-get update. Oh, magic happens. Oops, now we're at 1604 instead of 1604.4 instead of 1603.3 long-term support version, right? Great. Now we have actually different OSs because somebody went in and actually did this by hand, not by code. So what happens is, and you guys know how this works, if we go start deploying our applications, it'll happen like this. We go ahead and put Apache out there, right? Great. Works on the original intended version. We'll stuff another one out there because we're automated. And then we need 3 for scale. So guess what happens? He's going on the wrong OS. We know the shared libraries are going to blow it, and this is what, we get an atom bomb going off or something like that. So the system breaks. And that's exactly what configuration management is supposed to not do. And configuration management isn't somebody SSHing in and doing manual changes. It is codifying it so we don't end up in this situation. Snowflakes cause pain. And the worst of it is, if you're doing manual operations and not codified operations, you'll have snowflakes everywhere. And now you really can't actually find a problem because you have too much out there that's operating incorrectly. So how do we achieve consistency? Through immutability, right? So if we have automated means, Chef, Puppet, blueprints, Kubernetes manifests that we're tracking through version control, we've got a configuration management system that does the work for us automatically, then how do we really get consistent? Never change the systems, right? Cattles versus pets, never have a pet to the extent you can help it, right? So what is immutability? It really means something that never changes. And how do you do immutability with infrastructure, right? With applications, it's kind of easy. You've heard the term stateful and stateless apps, right? So a stateless app, who cares? Kill it and fill it because it's stateless, right? It's not storing state. Infrastructure is pretty stateful. It's really, really there. vCenter has a lot of data about what's going on. If it dies, you can't see things. So how do you deal with this kind of thing? Well, we know what the answers are. Code drift is okay though. Changing a system online is not okay, but code drift is okay. That's what Git is tracking for us, right? So we can change the code, we can change the chef cookbooks, we can change the bash scripts, we can change the Go code if that's how we're doing our work that's making REST calls. That's okay because we can track it. And if we can do that, then we don't end up in runtime drift, but runtime drift is not okay. You can't just send, you know, chef cookbooks at one server. You got to ship it against them all, right? You can't just fix one, fix them all. So we need that. Runtime drift is not good. And then turn off SSH. How many of you guys keep SSH on your servers? One guy, two guys, three guys. Yeah, you'll all raise your hand over time. I know how it goes. You don't want to admit it. Come on. Point being, if you turn SSH off, how many guys are going to scream? It's going to be hard, but it is what we actually like to do. No SSH. Right? Unless we need Ansible to run, we got to flip it on real quick and then flip it back off. Point being, you can't log in and fix stuff. You have to do it through code. So these are the kind of ways you can get to immutability. So what does immutability look like? Well, you need to change something. You don't change the thing. You change the code that's going to change the thing. And that's how that works. And then you push the code, right, to version control. You git add, git commit, and then git push. You do simple operations. And then you test that code in other versions of the pipeline. So catch this. If you're going to change the anti-affinity rules on a vSphere cluster, you really should test it in a different cluster with the application in a dev environment to make sure it's really going to work, right? Anti-affinity is there for a reason, right? Maybe we're running a quorum-based cluster that we have to have things in different failure zones, the servers in different failure zones. Well, if you turn anti-affinity off and you don't test it, and you lose a node, then you just lost quorum, you're now read-only, you can't change anything, right? That kind of thing. So it is important to test this stuff, and this is what, of course, Git allows. You checked it in, we can pull it, you know, we can trigger off some CI/CD runs and pull it and test it. So Immutable kind of works like this. It's thinking like this, if you look at the drawing on the right. When we actually make a change, we're going to kill the old system and put a new system online. So if we make a change that, for example, changes a Zookeeper cluster, if you're not familiar with Zookeeper, it's okay. We don't actually keep the old Zookeeper cluster. We replace it with new. We don't change the old one. That's crazy. You replace the servers online because you got to keep your data, but the new cluster will spin up and go ahead and pull the data in. So this is what we want. We actually want A to B switching, not modifications or patches in place. And that's how we get there. Pull a change request, code the change, commit it, and run it. And then the run should replace everything. That's the whole idea through the CI/CD system, and we'll take a look at that. So I have an example for you. I can do an immutable operation on vCenter. In this case, not vCenter, ESX, right? And you guys actually do it probably all the time. You just didn't consider it as an immutable operation. So when you're going to upgrade a ESX host, right, the first thing you do is put it in maintenance mode, you take it out of the cluster, and you do some work, and you put it back in, right? That's actually an immutable operation. So what happens is, the right way to do it is treat your ESX hosts as cattle. Don't consider them long-living things. Consider you're going to lose them, right? First principle of resilience is assume catastrophic failure and design your system around that. Don't assume availability. So what you do is you upgrade your host offline. It's a ESX host 99, I don't care what it's called. You go ahead and put that in place, right? And you codify this, of course, you're going to do it automated. We know what happens next. We've got to vMotion the application over to it, and then we can take the other one offline. That is an immutable operation, because what we didn't do was patch the ESX4 host itself by shutting down the apps, putting it in maintenance mode, taking it offline, up patching it, putting it back online, and then putting it back up. That's a change to the app. This is an immutable way of doing that, right? And it can be codified pretty easily. The same thing, I can do it at a cluster level if I'm doing vCenter, right? I'm not sure it's an app thing to do, but you can do it. You can actually do immutable operations on clusters itself, because we can add a new cluster, vMotion all the apps over, and the new cluster, of course, is our upgraded, who knows what, upgraded everything. And then we can take our old cluster offline. And we've done basically an immutable operation on the vCenter cluster itself, right? So where you hear guys at the CNA level writing containers and this and that, always talking about resilience and immutable operations, you can do it at the infrastructure layer just as well. You just have to understand that that is what's happening, and you have to codify it. And you're kind of in position to say, you know what, I am a dev. And that's where we really want folks. So where does that come from? It's all about CI/CD. How many of you are running pipelines for all of your code? Yeah, so lots of guys running pipelines. I don't know if you're using, what are you, Jenkins? What's everybody using, Jenkins or? What's that? Oh, okay, yeah, okay. Concourse, there's lots of them, right? And CI/CD is all about pipelining, so it's called a value chain, right? You put some stuff in, you're supposed to get high value stuff out, right? So when you put new code in, the idea is the CI/CD engine, Jenkins or whatever, will watch your Git repositories. When it detects a change, it'll pump it through the pipeline. And the pipeline is doing things like building code, taking all our infrastructure code, our application code, and our reliability code, packing it all together, and jamming it down the pipelines, making sure it's all good, testing it right. This is the whole point. And then outcome on the end of the pipeline is a working system or a broken system, and you go tell the developers. But either way, you got value out of this pipeline. That's the idea, why it's called a value chain. So when we automate things, what we want to recognize is that the three types of code need to go through the pipeline together. So when we modify, like I said, if we modify the anti-affinity rules, remember my comment was we should test the whole app again. It's not enough to test that the anti-affinity rules change worked. It's enough to say I did that and the application still works. So we have to pump the whole thing through the pipelines, not just the anti-affinity rules change, right? That's the key. So we need to get all of our feature code, all of our infrastructure's code, Kubernetes manifests, blueprints, this kind of stuff, all of our reliability code, which is dashboarding, right? Hooking up to logging, hooking up traceability, or tracing, right? Tracing systems and Zipkin, Jaeger, whatever you're using. All these things, you've got to hook them all up. So that we can even see if the app is running the way it's supposed to run, right? Observability is critical in these kinds of things. So we need all three kinds of code, and they all have to get pumped through the pipeline. And they're very likely living in different Git repositories, right? Your application code, your infrastructure as code, and your reliability code are very likely in different Git repositories. And this is why CI/CD is watching lots of different Git repositories to go make this magic happen. And how we want it to work, right? So you can see you commit any one of those, commit the anti-affinity rules change. It's going to pump all of this stuff through the pipelines. It's going to run it, it's going to test it. If it breaks, it's going to notify the developers that it's broken, but I have to change the anti-affinity rules, so we're going to have to change the app, right? This is the kind of thing that Steve said, if we don't need communication, perfect. We don't need it because they'll get it for free. They can communicate, which is good, right? Because humans want to talk to each other, but they don't need it. The system itself will tell them it's broken. And that's what we want for high-speed scalable operations. And with that, Steve's actually going to go through, as a non-technical person.
As a non-technical person.
Well, you're pretty technical. He's the most technical sales guy I've ever met. But he's going to walk through how it really, really works and the way we like to see it.
So I'm going to demo something. This is really about demoing the process here. This is not about how you should be doing account management in vSphere. So warning, this is just an example of showing something you could do, a methodology. This is not the recommended way to manage users in vCenter. Okay, so what we're going to do here is we've got this basic text file, and we're going to use this text file to configure the local SSO users on vCenter, okay? So it's real simple. I've got user. If it has an A next to it, that means you want to add it. If it has a D, you want to delete it. So we've got the basic file, and we're going to go in and edit it, and I'm basically going to delete the user, and I'm going to add another user. And after I do that, I'm going to commit it, and I'm going to push it, and the software pipeline, the CI/CD pipeline, is going to see those changes. It's going to do a quick validation of all the syntax and if the script is going to run correctly before it actually does anything. And then it's going to go ahead and actually do the activity. So it's going to go out to vCenter, it's going to parse and look at the differences, and then it's going to run the scripts that will actually make the changes. Okay? So what's in my toolbox? So in my toolbox, I've got CI/CD software. In my case, I'm using Concourse. I just chose it because I do a lot of work with Pivotal. It was their product. I figured I might want to learn their product. It was extremely simple to get up and running. It was 2 containers, literally. So I had, over on the right-hand side, you can see one of my tools is a container host. So I went out, Googled concourse, containers, found the link, pasted it into the CLI of that Linux box, I had it running. Then I had to actually go to Tom and say, how the heck do I actually configure concourse, which was a learning curve. But getting it up and running was easy. Of course, I got my source code repo, which is where all my code is sitting. So it's not just that admin.txt, it's all the scripts and everything else associated with it. And then, of course, on the far right, I've got the thing being configured, which is vSphere in this case. So what code is needed? Well, there's various amounts of code here. Creating the pipeline, I basically, you'll see how concourse works, but you create a pipeline with, basically, we have 3 YAML files, which describe the tasks and the jobs. Okay? So I can recreate this pipeline based on the information that I've got in GitHub. You also have the action that the pipeline performs. So you got the pipeline for one, and then the action of what it's doing. It's going out, it's comparing users, and it's actually configuring and doing things. Okay? So here's GitHub, here's my text file. So again, I've got concourse configuration information here in the upper right, and then I've got the scripts that are doing the work. In concourse, I've got 3 YAML files, basically, that describe the pipeline overall and all the various functions it's going to be doing. And then static test, which is kind of doing the kind of UAT type activity, and then runconfig.yaml, which is actually doing the configuration. So concourse is defined in these YAML files, and you can issue a CLI command to go, define the YAML and how concourse is configured. But instead, what we did the right thing. We created a script to do that, right? And so the other thing here, we've got parse account. So that's the thing that's going to go out to vCenter and actually compare the 2 files. So what it does, it knows admin users.txt. It goes out to vSphere then and compares what's in vSphere to what my admin.txt, and it makes a decision on, do I need to add or delete? So then I've got my 2 scripts down here, add user and delete user, and depending on what the results are that add and delete, it's going to run those 2 scripts. So pretty simple, right? But if you look, this is everything that's required. It's not just a simple 1 script and a text file. There's a lot of stuff involved here. But I was actually having a lot of difficulty with my lab environment internally, and I had to recreate this environment about 7 or 8 times. And because I actually had everything in GitHub, I could actually do it in about 15 or 20 minutes, which is pretty good. Okay. So up until 2 months ago, I hadn't done a live demo in like 5 years. So here goes. Let's see if I can do it again. So whoops. So let's go here. Okay, so the first thing we'll take a look at here is GitHub. So I've got a repo here called VMworld 2018. And so this is where all my code exists. And we'll go in just through the web interface of GitHub and make that edit to that text file. So here's all the files, and I'll go through all these files in just a minute. But the one we're concerned with right now is adminusers.txt. So I go in here, and you can see what's there. So I go in and I just do an edit on this file. And I'm going to do user add and I'm going to delete Thanos here. And so after I commit this, so I'm just going to do the proper thing here. So and commit the changes. So if we pop over to our pipeline here, the pipeline is basically describing kind of the stages here. So the first piece is I'm going to be watching GitHub. And when I see a change, you'll see it started here. And it will activate that piece. And then it moves on to this thing called the static test. And the static test basically verifies that the scripts are going to run correctly. And actually, if I go into static test here, you can see why you want to do this. Previously, oh, there we go. It's already kicked off. A little bit of latency here. I actually had a failed test as I was working through this. I mentioned I was having lab problems. So you can go look at this failed test, and in this case, it said it's trying to clone it, it's going out to GitHub, and it couldn't even resolve github.com. So it just failed, and the pipeline just stopped. So before it went out and tried to compare and add and delete, it basically stopped the pipeline and said, you got a problem, you need to go resolve it. So just committed. So there's the pipeline. Let me go back out. So it's running the test, and you can click in on these, I guess, and we can take a look at the run. There it goes. It's kicking off. So it's going through, and it's basically checking a bunch of syntax and so forth. Now, I don't use the web interface here for GitHub. I use something called VS Code from Visual Studio Code here. And so if we take a look at the whole the repo of all the code that's required, I basically have various directories. The big one here is like the CI directory. So the CI directory, that's what's defining how that pipeline is set up and how it's supposed to run. So note, and the scripts that it's going to use. So I've got the scripts, which are the run config and that static tests. And the tasks define what or how that thing is running. So if I click on run config, it's identifying, hey, you're going to go need to do this task. We're going to need a Docker image to do it. We're going to get our source from git s Tegeler, and so forth. Okay, let's see how our pipeline's doing. Oops. So we're still doing a running config. Should probably go hop over to vSphere here. See our users and groups. Probably should have shown this to begin with. There we go. So we can see this is still left over. It hasn't completed yet. There's the bad guy Thanos. And it's got some other ones in there as well. So if I refresh here. Still running. Could probably go take a look at the running config here, and you can kind of see the activity that's happening. So Tom wrote all this stuff. I was the product manager for his scripts, and he kept telling me, we don't need that feature, we don't need that feature. But in effect, you can go through and you can see what it's doing here. So it basically goes out and says, hey, show me the user Thanos, does it exist? And if it comes back, yes, it exists, then it's going to run that, basically the delete script for it. So it looks like it's done. So you can go back over here to the client and do a refresh. And there we go. So we've added the Star-Lord here, and we deleted Thanos. Now, what's Batman doing in there? Someone probably went around the pipeline and put Batman in there. Because no longer, that text file is no longer the single source of truth for what's going on. So again, we should probably shut off the GUI for vCenter? No, probably not a good idea, right? That's, okay. All right, so the last thing I'll show you here, this will be, of course, boring for those that understand and use GitHub regularly. But again, going back to tracking all these changes over time, you can go into any one of these files here. It's like adminusers.txt, and you can go through and look at the history of this file over time, and you can always see who made the changes and what the changes were exactly. So if we just kind of go in here, I think that'll show me the history, you can see the various changes. So obviously this is editing and deleting users, but what if you're changing that security policy, right? How can I easily kind of figure out what were the infrastructure changes? Oh, I went from 4 CPU to 8 CPU on a VM, and that was a point at which my performance got better or worse, for that matter, and you can go back and take a look. So that's the quick demo. So where do you start? So the big thing is you need to identify these repetitive tasks and stop making manual changes. Put the scripts, put configuration files in Git. Start using that as a tool. Pick something small. Parameterize your scripts, right? You don't want to have hard-coded IP addresses in scripts, right? That's a bad idea. You want to have maybe a configuration file with all that information that the script calls upon. CI/CD pipeline, that's big. So if you don't understand CI/CD or that process, I'd go find someone in your organization and start asking them about it. I mean, you can go to a class, and I'm actually have a question for you at the end of this of who wants a class on this type of stuff. But the best thing to do is to buddy up and to understand it from a peer. So how do I start? So again, find someone. Don't boil the ocean, right? Don't, just because if you're learning CI/CD, don't go out and try and learn a new programming language, right? If you know PowerShell, use PowerShell. Continue to use it, but let's just figure out how to get the operations correct around PowerShell and start using CI/CD. So the summary here is really stop clicking around and start coding. Check things in, start tracking all the changes, and it's hard in the beginning. Trust me, I really know. But as long as you can find someone to kind of help you out, then you're going to be far better off in your job over time. So who would go to a training class on all of this stuff? That was a quick hand back there. Would anyone go to like 1 day, 2 day, 5 day? What would it be? Or you don't know. There's a lot to learn. This is kind of a personal thing for me because, I see a lot of VI admins that they don't even know where to turn or where to even start. And I certainly see the need for this. It's just kind of hard, like, to go create a whole course in an ICM type thing on the SRE function, right? But thanks for that feedback. And actually, if you please do the survey here at the end, and if you want to put in the comments, I would definitely go to a class. Please put that in there because that's going to help me go lobby to have a class created here. Okay. A couple of additional pieces of information. So, what is site reliability engineering? We've got a blog post on it. And our professional services. So we actually have, there's a few people in our professional services organization that act like SREs, and they will come on your site and sit with you for some number of weeks and just start helping automate everything or anything that you want, right? So if you do want that peer and it doesn't exist or that talent doesn't exist in your company, we have services people that can come and sit there side by side and help you figure out how to do this. Maybe it's using VRO for that matter, right? How do I optimize that? But anyway. Okay, that's it. So again, please fill out the survey. Thanks for hanging around. We can take questions too if you'd like.
Oh, we do have some
Forgot
questions.
that. Yeah, go ahead. I'm sorry.
How would you store passwords?
Okay, so the question was how would you store passwords? So you never store passwords clear text, right? You always have a hash code or something like that. So what you can do, if you're familiar with, you guys are all familiar with Linux, right? You know what the password file looks like. There's actually a forward hash that you can store, so you can create a password hash. And you store the hash, because that's not reversible, right? So you can actually, it's called secrets management, right? This is what we're talking about. So secrets management, there are products for it too, like Pivotal has CredHub. There's secrets management things on public clouds. But generally stated, if you want to store a password in a text that you're checking into Git, you store only the forward encrypted hash, not the password itself, right? That happens a lot, by the way, with things like Chef and Puppet and that kind of thing, right? Yeah, and same thing if you're going to store a private cert, don't store the public cert, right? Things like that. Right. Yeah.
So in many companies you already have a kind of software pipeline. Would you recommend to use that for all that infrastructure code as well, or would you say build another pipeline that is more convenient for that infrastructure things?
If you want to cover that, all right.
So
I can cover it.
I mean, personally, if there's talent and skills at your company, and you can learn that existing tool, probably a good strategy. If you look at that tool and go, that is far too much complexity for what I need to have done, maybe you can use a different tool. But
for example, it's Jenkins. To me, it really looks complex.
Yeah. I think that, your question was if you already have a pipeline, should you use that one or another one? So that's kind of a two-part question. One is, if you have a pipeline manager, Jenkins, or with the Jenkins, pipelining plugin, or you have Concourse or something, all those tools aren't that hard to use, it turns out. They're just like anything else. You got to install them, you got to configure them, do the work, right? So that should be codified itself, by the way. But once you get there, the issue of building the pipeline itself, you saw the code, it's not that complicated. And if you have existing pipelines and you now want to add your infrastructure as code or add your reliability code to it. I wouldn't add it to that pipeline because pipelines, when they're successful, can trigger other pipelines. So you can chain these pipelines together. So you can put your infrastructure as code layer, for example, in its own pipeline. So when, for example, the static tests, we put it all static tests and then actual run tests and whatnot in the same pipeline. You can separate them. So you can do proper software orientation around pipelines themselves. So I wouldn't combine everything in one giant pipeline because then you got real problems when there's challenges in the pipeline. Cut it up.
I think sometimes we're intimidated, right? It's kind of scary because it's unknown. But I think if you sat down with someone for a couple hours and just kind of understand the basics, you'll find that, like Tom said, they all kind of work the same. So.
Yeah, he kicked me out. He said, no. After a couple days, it's like I'd say, Steve, you need help? No, I'm good. Get out of here.
Stop doing the work. I need to learn this. Yeah.
It only took him a couple days, which was, he's pretty smart, but so are you guys, I'd say.
Any other questions?
Awesome.
Great.
Thank you all.
Thanks for coming.